Okay, so let's go back to that original setup. We had these two polls about stem cell research. In 2002, 43% of a sample approved, and in 2009, 58% approved. So we're going to set this up, and technically it doesn't matter what you let population 1 or 2 be, but once you choose, you have to be consistent about it. So 2009 is going to be population 1 for us, and 2002 is going to be population 2. We want to find a 95% confidence interval for the difference in these, and then we want to interpret it. We want to say, do we believe the actual population proportions are different based on this? Okay, so does the CLT apply? Okay, we need to check all of the conditions. Okay, so first condition is, are each of the samples themselves random? So if we go back up to the very beginning, the first one said it was a random sample. And the second one, it says a new poll of a different sample. So this one doesn't say random, but the Pew Foundation was performing both of these. So I would say yes, they're both going to hit the random criteria. Okay, then we have to check this one. Are each of the samples themselves big enough? So for sample 1, there were 1,500 people sampled, and the probability was 0.43. So we have to check, is that bigger than 10? And we also have to check, is this one greater than or equal to 10? So we can check both of those. I'll leave that up to you if you check both of those. They certainly are both bigger than 10. Okay, and then we have to check, are each of the that was only for the one part of them. So this would be in 1 P1, and this is into P2. So in addition to this, we have to check so if we take that 0.43 and we subtract it from 1, we get 0.57. Is that bigger than 10? And we have to do the same thing here. 1 minus 0.58 for 2. Are these all bigger than 10? Yes, they are. So it's a lot of checking. There's a lot of checks that you have to perform here to make sure these are going to work. Take my word for it, these are. Check them for yourself. They are. And then the very last one that we have to check are both of our populations big enough? So the population, the big N for each one of these, they were surveying Americans. So is the American population bigger than, 10 times in what? So is it bigger than 10 times 1,500? Yes. And in the second one, it's actually the same. The sample sizes, this 1,500 happens to be the same. So the American population is bigger than that again. Technically, that's two different checks. This was just unique in the fact that both of the samples were of size 1,500. And are the samples themselves independent from each other? So do the people in 2002, can those people affect the people in 2009? They shouldn't, as long as this was really a true random sample. It shouldn't be the same people, or they shouldn't be related in any way. It should be a totally different group of randomly selected people. So in that way, one of those should not affect the other one at all. Okay, so once we've checked all of the conditions, we basically we need those successes and observations for each sample. So let's see, we're going to have to do a little bit of calculating there. Our number of observations for each of them is 1,500. And then how many successes were there? Like how many people said they agreed here? Well, in this one, in the first case in 2009, we have 58%. So what is 58% of 1,500? And in 2002, it was 43%. Make sure I remember. Of 1,500. And that's going to go in as our number of of successes. So it looks like for 2002 should be 645, and for 2009 it should be 870 if you calculate that out. Okay, that's all we need in order to put this into StatCrunch. So I'm going to flip over to StatCrunch here, and I'm going to go into my stat, and we are still under proportion stats for chapter 7. So the difference here is I'm actually going to choose 2 samples with a summary, and I'm going to input that information there. So my sample 1 was the 870 out of 1,500, and my sample 2 was the 645 out of 1,500, and I'm doing a confidence interval for P1 minus P2, so it does matter. You have to make sure you get your sample 1 and sample 2 in the correct places because we're subtracting in a particular order. 95% is the level of confidence we want, so I'm going to click compute, and here are the values that I get. Okay, so I'm going to flip back over and I'm going to record that. Okay, so the resulting 95% confidence interval that I get is 0.114 approximately to 0.185. Okay, so if I want to interpret this now, what I'm most concerned about is what I look for is 0 in there. Is 0 in the middle of those numbers? The answer here is no. So I might say something like, since 0 is not included in this interval, what they're saying here, again, these numbers came from subtracting the values. So we've subtracted the values, the different options for the values, and we never got 0 as an option. So what that tells me is that I'm going to conclude that these 2 population proportions really are different. So something like, I am confident that these 2 population proportions are different. So I don't think it's the case that the public opinion has actually somehow stayed the same between these years. These percentages have come back different enough that I'm convinced that there really has been a change in the public opinion about this. And moreover, since all the values in this interval are positive, that tells me a little bit more information. So again, I'm going to, just out to the side, remind myself, we're doing P1 minus P2, and what we've just discovered is that all of the possible values for this that we are confident in has come out positive. So if all the values for this subtraction have come out positive, and I do that little move again, what that is telling me is I'm confident now that the P1 is actually bigger than P2. So P1 is 2009, P2 is 2002. So at this point, I'm confident that the 2009 percentage is truly higher than the 2002 percentage. So that's why I'm going to finish my sentence here. Since all the values are positive, I am confident that the 2009 percent is truly higher than the 2002 percent. And again, we are talking about the overall percent of what all Americans think here, not just the sample. The sample percent, of course, it was bigger. We knew that from the very beginning. That was not in question.